Okay, so today's lesson I'm going to talk about similar triangles, but more broadly than that we can talk about similar shapes. Now, if any two shapes are mathematically similar, and I mean mathematically, not just the English word similar, which means that you might have some things in common, but if something's mathematically similar, then there are two rules that they must follow. Now, those two rules are that all corresponding angles are the same or congruent, if you want to use a mathematical term, and the second one is that all the corresponding sides are in the same ratio. Now, why then do we talk about triangles in particular in maths? And triangles have actually got a very, very special property, and that special property is that if one of these rules is true, then the shapes are mathematically similar, and therefore the other rule is also true, and that is only true for triangles, no other shape. So it's very, very special indeed. Now, when you get a question on these then, as long as you can show that, and in most cases it will be the angles, as long as you can show that all the angles in the two triangles that you've got are the same, then they're mathematically similar. So I've got an example for you here. Now, in this example, what I've done is I've used symbols to represent the angles. It doesn't matter what the angles are as long as they're the same. So I've got two triangles. This one is slightly smaller than this one, and as you can see, I've labelled the angles. So this angle's got a single line that corresponds to that one. That means those two angles are the same. I'd like to point out this is a sketch. It's not an accurate drawing, it's just a sketch. The dot means these two are the same, and the double lines means these two angles are the same. So therefore, because I'm telling you from my annotations on the triangles that the angles are the same, then therefore we know they're mathematically similar, and therefore we can use the second rule, which is that all corresponding sides are in the same ratio. Now, what does that mean? Well, it means essentially with similar shapes that one shape is an enlargement of the other one. So if one shape, say we have a square, if all the sides of a square are say 1 centimetre each, and then you've got another square where all the sides are 4 centimetres each, and the scale factor between the two is 4, so you're just multiplying each of the sides by 4 to get the other shape, and you can do that with any shape at all you like. So essentially we're looking at an enlargement. So if that's the case, the first thing that you need to do is you need to find the scale factor. Okay. So for this question, we've got some sides, we've got some unknowns, which if this was a proper question it'd be written out, please find the value of x and the value of y, etc. So that's what you're trying to find here, but the first key whenever you've got similar shapes is to find the pair of corresponding sides, so the pair that you've got, the corresponding side on each shape. And in this case, if you look here, between the single and the double line on this side, on this triangle is 3 centimetres, and if you look over here between the single and the double line, so it must be the corresponding side, that's 9 centimetres. So this side here corresponds to this side here. Okay. Now, to find your scale factor, the easiest thing to do is to do the biggest side divided by the smallest side. So we're going to do 9 divided by 3. 9 divided by 3 is 3. So our scale factor is 3. So in other words, if I want to go from a side on the small shape to a side on the big shape, I need to multiply by 3. But importantly, if I want to go from a side on the big shape to a side on the small shape, I need to do the opposite. I need to divide by 3. All of the sides are in the same ratio, and that ratio is, or the scale factor is 3. Okay. So we can find x and we can find y now. Now it's actually easiest to find y first, because y is on the bigger side, and most of the time we find it easier to multiply than divide. So if we're going from small to big, to find y we're going to have to multiply by 3. So we've got to find its corresponding side. So y goes between the dot and the double line. Find that side on here, it's the 7. So y is quite simply just equal to 7 times 3. So therefore y is 21 centimetres. Okay. Now we need to find x. Now for x, it's a little bit more tricky, but we can still do it, it's not a problem. So to find x then, okay, we need to find its corresponding side on the bigger shape. So x goes between the dot and the single line, dot and single line, so it's 17 centimetres. Because we're going from big to small, we divide by 3. So therefore it is 17 divided by 3. Now when I do divide, I prefer to write a fraction bar, because I find it easier to deal with. If I try to do 17 divided by 3 in my head, sometimes it doesn't work properly depending on what time of day it is. So the easiest thing to do is to think about it as a fraction, and then I can say to myself, how many whole ones go into it? Well, I know 15 is a multiple of 3, and that's 5 3s, so there must be 5 whole ones, and I've got 2 left over to get to 17, so it's 5 2/3. So that means that I can do it without a calculator, and obviously don't forget your units at the end. So that's quite a nice, simple, straightforward, similar triangle.